Alright, so in this video, let's take a look at indefinite integrals, and we'll look at some definite integrals and the net change theorem. Alright, so an indefinite integral, the integral of f of x dx is equal to capital F of x plus c, means that the derivative of big F is equal to little f. So for example, if we integrate x squared, that would give us 1/3 x cubed plus c, because if we take the derivative of this, of the 1/3 x cubed plus c, see we take the derivative of it, we get x squared. Okay, so the x squared, that's the little f. This 1/3 x cubed is big F, and then see if we take the derivative of capital F here, so that means we're taking the derivative of this, which gives us little f, the x squared. Alright, so an antiderivative represents an entire family of functions, one for each value of the constant c. Okay, c is just some constant. So you should distinguish carefully between definite and indefinite integrals. A definite integral is the integral from a to b of f of x dx. That's a number. Where an indefinite integral is a function or family of functions. All right, so that's the difference between them. So now let's take a look at the table of some integrals. So I'm not going to read through all these. You can pause the video, copy them down, and look through them. So I'll just go through a couple of them. So we've got the integral of c times f of x dx. Well, c is a constant term, and what this property is telling us is that we can take a constant term and pull it outside of the integral. Okay, and then this one is telling us if we integrate a constant term, k is a constant, then it's just that constant term times x. All right, and plus c. I'll talk about the plus c in a minute. And this term, this one over here, if we have the integral of f of x plus g of x dx, well, what this is telling us is that if we have multiple terms that we're integrating, then we can integrate each term individually. And then this one, the integral of x to the n dx. So what this one's telling us to do is the exponent here, we add 1 to the exponent, and then we multiply by the reciprocal of this new exponent, the 1 over n plus 1. And of course, an n cannot be -1. So this exponent here can't be -1. All right, and then you've got the other ones here, integral of e to the x, and then you've got your trig function, see sine, secant squared, secant tangent, and all those. And then you've got your arctan, arcsine, or inverse tan, inverse sine, and your hyperbolic functions. This is some of them. There's more, but we're just going to kind of concentrate on these. You can look the other ones up. Now, notice all of these have a plus c after you integrate it. There's a plus c there. You have got to put the plus c, okay, because it's plus some constant. Okay, c may be 0, okay, but we don't know, unless we get some conditions, that where we can solve for c. But just don't forget the c. All right, so let's go ahead and take a look at some examples. Now, just remember, whenever you're integrating, you've got to integrate something that looks like what we have in the table here, okay? Because this is what we know how to integrate. All right, so let's come over here and look at the first one. It says find the general indefinite integral. So we've got the integral of 10x to the fourth minus 2 secant squared x. All right, so we're going to integrate each term. All right, so if you notice this x to the fourth, that's in the form over here of this x to the n. So we can add 1 to the exponent and then multiply by the reciprocal of the new exponent. All right, so let's look at that. So this is going to be, so we've got the constant term. It's just going to be the 10. It's just going to kind of tag along with it. And so the x to the fourth, we're going to add 1 to the exponent. So 4 plus 1 gives us the 5. And then we multiply by the reciprocal of the new exponent. So that's 1/5. All right. And then we have minus, and then we have this 2 here. So that's 2. Now let's look at secant squared x. Okay. See, the 2 is just going to be multiplied along. Like, see this right here? So we can, it's like that 2, we can bring it out and then just integrate the secant squared, that function. All right, so do we have anything over here that looks like that? Well, yeah. You see here, secant squared, the antiderivative of secant squared is tangent. Okay, so we come back over here, and the antiderivative of secant squared is tangent x, and then don't forget your plus c. And there's your answer. All right, let's look at the next one. All right, so this one, if you look at the table, okay, hopefully you wrote the table down. If not, rewind the video, write it down so you'll have it in front of you. So if you look at this, we got the integral cosine theta over sine squared theta. Now that looks like nothing in the table. Okay, so we're dealing with trig functions. So the ones that we have are let's see, this one are here and here. There's our trig functions. So we've got to see if we can make that look like one of these. All right. So let's look at this. Well, I may need to rewrite this thing. All right. So if we write this, we can write, well, let's see. We've got cosine in the numerator. We've got sine squared in the denominator. Well, look, if you take cosine theta, and let's just look at this. Let's write sine squared theta as sine theta times sine theta. All right, let's see what happens. All right, so we've got cosine over sine times sine. All right, so remember we've got cosine over sine times sine. I know I didn't put the theta. All right, so can we make it look like one of these? Well, if you look at it, do you see here I have a 1 over sine and I have a cosine over sine? Well, 1 over sine is cosecant and cosine over sine is cotangent. So you can see we've got this one right here. So let's go back and write this as 1 over sine theta times cosine theta over sine theta d theta, which that is equal to, let me come down here and write it. Let's erase that. So this is going to be, well, 1 over sine is cosecant theta, and then cosine over sine is cotangent theta d theta. And then by that integral in the table, that is just negative cosecant theta, and then don't forget your plus c. So a lot of these integrals, what you're going to have to do is you're going to have to rewrite these things to make it look like one of these in the table. Okay, you're going to do a lot of that. All right, so let's look at this problem. So this one here is a definite integral. See, we've got the limits on the integral here. So let's just integrate it. So x cubed. So remember, I add 1 to the exponent, add 1 to the 3, and then multiply by the reciprocal of the new exponent. And then that's minus, and then 6 times, and then I've got x to the first power. So I add 1, that's going to be x squared, multiply by the reciprocal of the new exponent, so that's 1/2, and that's evaluated from 0 to 3. So let's go ahead and just kind of clean this up just a little bit. All right, so all I did is just 6 times 1/2 and got the 3. All right, so now let's plug this in. So I'm going to evaluate the function at 3. So that's going to be 1/4 times 3 to the 4th minus 3 times 3 squared minus, okay, so I evaluate the function, I'll evaluate this at 3, and then minus, and then I evaluate it at 0. And of course, when we plug 0 in, we can see we're going to get 0, but let's go ahead and plug the 0 in. All right, so now this is going to be what? 81 over 4 minus 27. All right, and that's going to give us negative 27 over 4. All right, so how about the next one? All right, so I've got the integral 2x cubed minus 6x plus 3 over x squared plus 1. And that's going to go from 0 to 2. All right, so the ones here, the first two terms, well, that's easy to integrate. That's just that power rule, x to the n. But what about this one? Okay, so if you think about the table over here, well, when we look at this, you see this 1 over x squared plus 1. I know in ours we have a 3, don't we? All right, so this next step that I'm going to do is not really necessary, but it may help you see it. So I've got 2x cubed minus 6x plus, and then let's do 3 times 1 over, 1 over, okay, so we've got x squared plus 1. Well, see, there's the 1 over x squared plus 1 right there. All right, so let's go back. And that's going to be x squared plus 1 dx. And so this is going to give us, so let's go ahead and integrate. So I've got x cubed, so that's going to be x to the 4th, and then I'm going to multiply by the reciprocal of my new exponent, which is 1/4. 1/4 times 2 is 1/2 minus, and then the antiderivative of x, that's going to give me x squared, and then times the reciprocal of the new exponent, which is 1/2. 1/2 times 6 is 3, and then that's going to be plus 3, and then remember this one from the table, 1 over x squared plus 1, that is inverse tan x, and that's going from 0 to 2. All right, so now let's evaluate this. So I'm going to plug the 2 in, so I get 1/2 times 2 to the 4th minus 3 times 2 squared plus 3 times inverse tan of 2 minus, and now I have to plug the 0 in. And of course, when we plug the 0 in, we're going to get 0 for the whole thing. But let's go ahead and plug it in so we can see it. All right, so that's minus 3 times 0 squared plus 3 times inverse tan of 0. All right, so of course all of this goes to 0. So I've got what? 1/2 times 16 is 8, and that's going to be minus 12 plus 3 times inverse tan of 2, which that's going to be what? Negative 4 plus 3 inverse tan of 2. And so this is your answer, or you could punch this into a calculator. So that's negative 0.678, and we'll round it to 4 decimal places. So this or this is an acceptable answer. Now make sure that when you're doing this in your calculator that you put your calculator in radians. Okay. All right, so let's look at this one. All right, so evaluate this. So you can see here, and I'm not going to go back to the table, but this looks like nothing in the table. So what we're going to have to do is rewrite this thing so that it does look like something in the table. Okay, so I know how to integrate some trig functions, and I know how to integrate x to a power, something raised to a power. All right. Well, this one, I could split this up. Okay, so I could split this up into 2t squared over t squared plus, now let's look at this one. This is t squared times the square root of t. All right, so if I write that, I have t squared times the square root of t over t squared. All right, so what happens here is, look, the t squareds will cancel, right? And I'll be left with what? T to the 1/2. All right, so let's go ahead and just write that as t to the 1/2. You can see the t squareds cancel. And then I have minus 1 over t squared, and that's dt. All right, so I still have to do some more rewriting. So, because remember, all I know how to do is integrate t to a power. So this is going to give me integral 1 to 9. Well, here the t squareds cancel, so I'm left with 2. Plus, now the t to the 1/2, that's fine. So t to the 1/2 minus, now this 1 over t squared, I have nothing in the table that tells me how to integrate 1 over t squared. But I do know how to integrate t to a power. So I can move this up into the numerator, and remember what that does is it changes the sign of the exponent. All right? And so now I'm ready to integrate. So the antiderivative of 2 is 2t. Remember that in the table, if we integrate a constant term, where is it? Here. If we integrate a constant term, that's just that constant term times x. Now what I do want to do is I want to come over here and go off to the side and show you how that works. All right, so if we integrate 2, in this case we're integrating 2. So what you've got to understand is 2 is the same thing as 2 times t to the 0, because t to the 0 is what? 1. And so what do we do here? We add 1 to the exponent. So let's write our 2 down. We add 1 to the exponent, so that's t to the first power. And then remember, you multiply by the reciprocal of your new exponent. So the reciprocal of 1 is 1 over 1, and so 2 times 1 is 2, and t to the first, so there's your 2t. Okay, so that's how that works out. All right, and then we integrate the next term, so that's plus, and that's going to be t. We add 1, that's going to be 3/2 multiplied by the reciprocal of the new exponent. So that's going to be 2/3. And then we've got minus, add 1 to the exponent. So that's going to be t to the -1. And then multiply by the reciprocal. So that's going to be 1 over -1. And then that's going to go from 1 to 9. All right. So let's kind of clean this up before we plug everything in. So that's going to give me 2t plus 2/3 t to the 3/2 plus 1 over t. The two negatives, that gives me the positive, and then I move this back down to the denominator. And so that's from 1 to 9. All right, so now let's start plugging everything in. So this is going to be 2 times 9 plus 2/3 times 9 to the 3/2 plus 1 over 9 minus, and then I have 2 times 1 plus 2/3 times 1 to the 3/2 plus 1 over 1. All right, so that's going to give me 18. The 2 times 9 is 18. Now, let's look at this term. I've got 2/3 times 9 to the 3/2. Well, remember, 9 to the 3/2, that's the square root of 9 cubed. Okay, so the square root of 9 is 3. Raise that to the 3rd power, that's 27. And so I have 2/3 times 27. Well, that's 9, and that is 18. So plus 18 plus 1/9, and then minus 2, and then 1 raised to the 3/2 is 1, so that's 2/3 plus 1. And then if we can, add that up or put it in your calculator, but after you do all that, you get 292 over 9. Okay. All right, so now let's look at this, at the net change theorem. Okay, that was indefinite and definite integrals there. So the net change theorem, it says the integral rate of change, the integral rate of change is the net change of big F prime of x dx from a to b is equal to big F of b minus capital F of a. So, and here's an example of that. If an object moves along a straight line with position function s of t, then its velocity is v of t equals s prime of t. So remember, if you have a position function or a displacement function, and you take the derivative of that, that gives you the velocity. All right. So in this problem, we've got what? We've got v of t, okay, v of t, the integral from t1 to t2 is equal to s of t2 minus s of t1. All right, so here's your v of t right here, and then here's your s of t2 and s of t1. That's this, because remember, s is the antiderivative of the velocity, okay? And this is the net change of position or displacement of the particle during the time period from t1 to t2. All right, so let's look at some more. So if we want to calculate the distance the object travels during the time interval, we have to consider when the velocity is positive and when the velocity is negative. So when the velocity is positive, it moves to the right, and when the velocity is negative, it moves to the left. Okay, so in both cases, the distance is computed by integrating the absolute value of the velocity function, the speed. So the total distance traveled is the absolute value of the velocity from t1 to t2. All right. So you've got to do the absolute value to do the total distance traveled. So all right. So let's look at this. It says a particle moves along a line so that its velocity at time t is v of t equals t squared minus t minus 6 measured in meters per second. Find the displacement of the particle during the time period 1 to 4, and then find the distance traveled during this time period. All right, so before we look at this problem, let's take a look at this real quick, okay? Maybe it helps us understand it. So let's take a look how displacement and distance traveled can be interpreted in terms of areas under a velocity curve. All right, so here we have a velocity curve from t1 to t2. This is our t-axis, and here's v. All right, so here's an area, here's an area, and here's an area. So this area A2, that's underneath the curve. Okay, there's your negative value. So the displacement, okay, the displacement is the integral of the velocity from t1 to t2. So we're going to add the areas up. So we got a1 minus a2 plus a3. Okay, this area of a2, that would be subtracted off. It's underneath the curve. Okay, and then the distance is the absolute value of the velocity from t1 to t2. And we would add the areas up, a1 plus a2 plus a3. All right, so now let's come back here and look at this. All right, so let's first find the displacement. Okay, so remember the displacement, that's just integrating this, integrating v of t from t1 to t2. All right, so let's do that. So we've got the displacement is equal to the integral. Now we're going from 1 to 4 of t squared minus t minus 6 dt. All right, so that's going to give us, well, we integrate this, that's going to be what? T cubed multiplied by the reciprocal of the new exponent, which is 1/3, minus, and that's going to be t squared multiplied by the reciprocal of the new exponent, which is 1/2, minus 6t, and that's going from 1 to 4. Okay, so this, what we're working right now is part A. All right, so now let's evaluate this, and so that's going to be 1/3 times 4 cubed minus 1/2 times 4 squared minus 6 times 4. And then that's going to be minus 1/3 times 1 cubed minus 1/2 times 1 squared minus 6 times 1. And then after you evaluate all of that, let's just go ahead and kind of do one more step. So 4 cubed, that's going to be 64 over 3 minus, well, that's 16, so that's going to be 8 minus 24 minus, and that's going to be 1/3 minus 1/2 minus 6. And then when you do those calculations there, you're going to end up with negative 9/2. Okay. So this means that the particle moved negative 9.5, or we could say 4.5 meters to the left. Okay, so that's what that, because 9/2 is 4.5. All right, so that's part A. Okay, that's the displacement. It moved 4.5 meters to the left. All right, now let's look at part B. All right, so now for part B, where they want us to find the distance traveled during this time period. All right, so can we just integrate the function like we just did? No. We've got to integrate the absolute value of the function. All right, but what we need to do here is just kind of not necessarily graph the function. I mean, you can graph the function, but we need to see over what intervals the function is positive and negative. So if we take our function v of t, and we've got t squared minus t equals 6. If we factor that, that's what, t minus 3 times t plus 2. All right, and if we look at this on a number line, because if we set this equal to 0, we have zeros at what? Negative 2 and 3. And so let's split this up. And so if I take a test value, so I've got t equals negative 3, and let's do t equals 0 and t equals 4. And let's plug each one of these in to here. So if I plug the negative 3 in, that's going to give me what? Negative 6 and negative 1. So a negative times a negative is positive. So that tells me this interval, the function's positive, from negative infinity to negative 2. And then if I plug the 0 in, well, I get what? A negative, because that's going to be negative 3 times 2. Negative times positive is negative. So it's going to be negative here. All right. And then if I plug the 4 in, that's going to be a positive times a positive, which is positive. So I can see that my velocity function is negative from negative 2 to 3, and it's positive from negative infinity to negative 2 and 3 to infinity. But if you look at it, all I'm interested in is from 1 to 4, because that's what they're wanting us to find over that time period. All right, so I can see here this is negative. Okay, that's negative. And this interval is positive. So what am I going to have to do? Are you kidding? All right. So when I integrate this thing, I've got the distance traveled is going to be the integral of what? Absolute value of v of t dt from 1 to 4. Okay? But see, here from 1 to 3, it's negative, and from 3 to 4, it's positive. So I'm going to split this up into two integrals. So I'm going to go from 1 to 3, the absolute value of v of t dt, and then plus from 3 to 4 v of t dt. Okay, see, I don't need to put this in absolute value because I know it's positive. Okay, see, it's positive. So here, this is going to be what? 1 to 3. Now, what's the absolute value of v of t? Well, that's going to be what? Negative v of t, right? Because it's negative. So the absolute value of a negative, well, remember this, the absolute value of x is equal to x if x is greater than or equal to 0, and negative x if x is less than 0. Okay, that's back from your first calculus class. You learned that, and that's even back in algebra. All right. So, and that's going to be dt plus, and that's going to be 3 to 4 v of t dt. All right, so let me erase this so I can have some more room. All right, so this is going to give us the integral 1 to 3. Now negative v of t, that means I'm going to distribute a negative to each term. So that's negative t squared plus t plus 6 dt plus, and that's going to be 3 to 4 of t squared plus t plus 6 dt. So now let's go ahead and integrate this. So that's going to be what? Negative 1/3 t cubed plus 1/2 t squared plus 6t, and that's going to be from 1 to 3, plus, and then this one's going to be what? 1/3 t cubed plus 1/2 t squared plus 6t from 3 to 4. All right. So now let's plug all this in. I'm going to plug it in and then just write the answer down, and I'm not going to go through all the arithmetic. But let me erase this and do it up there. All right, so let's get this. So that's going to be what? Negative 1/3. Now plug the 3 in. That's going to be 3 cubed. And then plug the 3 in here. So that's going to be plus 1/2 times 3 squared. And then the 3 in here. So that's going to be plus 6 times 3. And then minus. And then we got to plug the 1 in. So wherever there's a 3 here, that's going to be replaced with a 1. And so that's going to be negative 1/3 times 1 cubed plus 1/2 times 1 squared plus 6 times 1. And then plus, and then I've got to do this one. Okay, I've got to do this one. So let's come down here and continue. So I'm going to plug the 4 in. So that's going to be 1/3 times 4 cubed. And then plug the 4 in here plus 1/2 times 4 squared. And then the 4 in here, so plus 6 times 4. And then minus, and then I've got to plug the 3 in to here. So basically wherever there's a 4, I'm putting the 3. So that's going to be 1/3 times 3 cubed plus 1/2 times 3 squared plus 6 times 3. And then when you calculate that and punch it in your calculator, or do it out by hand, whatever, you end up with 10.17 meters, and that's your answer. All right, so I know the video was a little long, but hopefully it helped. Check out my other videos. Give me a like, share, and subscribe, and thanks for watching.